we have a prominent Indian scientist who is at equivalent level of senior professor, that is Scientist G, at the Defense Research and Development Organization, DRDO. Dr. K. Kadirvel is joining with us. He is currently the Scientist G at Defense Bioengineering and Electromedical Laboratory, a lab at DRDO. He is also Additional Director and Coordinator of the DRDO Industry Academia Center for Excellence at Bharatiyar University campus. And he is a specialist in environmental sciences and is also Additional Director of DRDO Industry Academy Center for Excellence at Bharatiyar University. Since his expertise is in the field of environmental sciences, I hope we will have greater amount of ideas from him to apply for climate changes and environmental studies, environmental protection, including environmental humanities. With this brief intro, may I hand over the session to Professor Kadirvel. Over to you, sir. Thank you very much. Hand mic, sir.
Good afternoon, everyone. First of all, let me thank authorities of Bharatiyar University for giving this opportunity to come over here, especially share about the funding opportunities for academia under DRDO. I think morning several speakers spoke about how to write a proposal, how to catch the proposal and success rate, all those things. I will not be touching anything about the proposal writing. Straight away, I will be, talking about the opportunities under DRDO. If you carefully see can I see next slide? See, this is, as you all know, under the Ministry of Defense, we have a DRDO, Defense Research Development Organization. So one of the biggest R&D establishment in terms of manpower, budget, and establishment. So still 1980s, we are completely classified organization. And also we have not taken any much major programs. Everything like academia, we are also doing basic research as well as certifying the imported weapons. If you look at over the period, today we have got 50 plus laboratories. If you look at this particular organization as a brainchild of Prime Minister, especially for making this country self-reliant defense system. So those days we had two establishments. One is Technical Development Establishment with the Indian Army. Another one is the Director of Technical Development and Production with Defense Science Organization. About less than 1,000 people. Till 1982, we did not have major programs. If you look at today, over the periods, we have completely from agriculture to missiles technology we are handling. And also, here the thing is it's completely an appliance agency. Whatever we do is for enhancing self-reliant defense system. That is the major aim. We undertake the design and development of any R&D. It has to lead to the product. Because not only product, it has to be world class. Why it has to be world class? The geopolitics. Even though Indian neighbors are not economically or technically developed, for that you cannot underestimate people. So-called developed country can support our neighbors to operate against it. That's why the world-class weapon system is very much in the need. And also, we need to develop as per the express needs of Navy, Army, and Air Force. That was our major mandate. And also, if you see the military technology like aeronautics, armaments, combat vehicle, electronics, instrumentation, engineering, all those technologies are going to be useful when you have a conflict with somebody. If you see, look at the last the point, we call it a soldier support systems. Under that, we have 9 laboratories. It becomes very, very important. Even though India is pioneer in some of the areas like, if you look at the supersonic or hypersonic cruise missile, only Russia and India today have technology. If you look at the operating the submarine using nuclear reactor, only 6 countries got technology. If you talk about aircraft engine, fighter aircraft engine, only 7 countries have technology. Ballistic missile, only 5 countries, especially the Agni. you know, all of you, this organization also highly woman-empowered organization. After Kalam, even today, the Agni is being managed by women empowerment. All of you know Agniputri, Divyastri, Agniputri, Deshi Thomas, Dr. Deshi Thomas. Then Divyastri, Dr. Seema Rani. Now, another scientist from Trichy, NIT, is going to take over Agni. Sivasankar, just 46 years old. This is what, out of 6 director generals, we got 12, 6 are them from women. So, what I want to convey, this equally empowered organization. And also, you can see, particularly in Indian system, our weapon system platform or technology is very, very complicated. The reason is, unlike other countries, India is Indian subcontinent, our soldiers are operating in the -50, +50, jungle, underwater, air, bunker. The new emerging, future going to be completely different conflicts. There won't be a conventional war. Look at the way things are going globally. Nuclear, chemical, biological, knowledge war, cyber war, trade war, economic war. By and large, we look at the chemical, biological aspect. India is also signatory, like our atomic energy. We are doing as per the declaration as well as our commitment to the international scenario under UN body. That way, that's why whether you have war or not, we have to make our soldiers comfortable in the different. Say, for example, when you take up the fighter pilot as an example, it's a very, very complicated job. The moment he takes up, he goes several times anti-G. Entire blood of his body will go to legs. So we need to develop the anti-G suit. You can buy a Rafale, but nobody will support you with the anti-G suit. Again, we have to support him to breathe with the proper oxygen. Say, for example, we are all breathing 20.8%. Moment you go to hospital ICU, 93.8%. For fighter pilot, we need to support them with the 100% oxygen at 50,000 feet. It's a very, very complicated job. Even after that, it takes only 3% the alveoli, 0.3% the ATP cycle. For that, you know how much you have to, 100% oxygen supply you have to give. So these are all critical technologies. And again, we need to develop the anti-G suit to support him and again, if you see this, just 1.3 kg helmet. He goes 10 times again gravity, 13 kg on his head. So all this, and also command, control, navigation, listen to enemy, expect radar, bomb delivery, complicated job. So that's why we are there to develop the life support system for armed forces. Anyway, I will be talking about entire opportunities. However, I will be highlighting about our basic, out of 7 clusters, 1 cluster is SSS, soldier support systems, that I will be highlighting. So the organization is empowering the organization with continuous defense technologies. Mission, design and develop, lead to the product, and then provide the technology to the armed forces to have better combat effectiveness. Very, very importantly, the development of infrastructure is very crucial because every infrastructure is a huge investment. And then the quality manpower. If you look at the one Agni program or even Chandrayaan program, any other program, we need to work 1,000+ engineers and scientists together to achieve a single mission. So here, the human engineering becomes a very, very important part. That for information, all globally, India is only country at 200 scientists working under Government of India under DRDO for recruitment through SSBs, follow-up profile, human engineering. They take care of everything, including their all aspect. We have a system in place. That's why we have a very strong quality manpower. So as I already mentioned, we have all of you know that India got a huge seashore, 7,000+ kilometers. We have been thought that highly secured. No, that is not the case. Can you believe people like us sitting like this 3 months in the submarine below 200 meters below water? They have to breathe same air. Can you understand the complication? They cannot cook food. They cannot do anything. They have to breathe the same air. See the complexity of the zone. If there is any accident, when you're exposed to if you go to every 1 meter below the water, there will be a huge pressure on it. You will become nanoparticle by the no movement because of pressure. For that, we need anti-G suit. And also, you have to make soldier to breathe 200 meters below water. So these are the complexity. So that's why we are there to support, and also you can see and again, materials. I think now if we talk about transdisciplinary, interdisciplinary, the material science plays a very, very important role. If you go to doctor, You should be extremely good in the material science knowledge, bone implant, dental implant, imaging system, drug delivery, drug loading. All things are material science. You go to take any sensor, advanced materials. You take any composite materials. So if you take camouflage material, stealth material, every aspect material science plays a very, very important role in terms of their all international research. And also you can see especially for naval system, especially for long endurance, we need a battery, we need to have anti-fouling material, we need to have anti-corrosive material, anti-microbial, so anti-skipping material. So for example, when you go to fighter pilot take a 5-kilometer runway, you got the airport, the Air Force. The same aircraft has to land and take up in the 400 meters. See the criticality in that. So these are the criticality. So that's why we have got a lot of system in place. Aeronautical systems for all, now future become completely unmanned. Now drones are playing very important role. So we have got a lot of other, and then armament combat vehicle for Pinaka, multiple rocket launcher, small arms, and then missiles and strategism. Whether it is to demonstrate our technology, to become global power, we need to invest a lot in the missile system. If you look at Indian missile system, we got technology from 4 kilometer to 8,000 kilometer. From ballistic missile, air-to-air missile, even cruise missile, anti-tank missile. Like that we have got number of even anti-satellite missile India could make it in 2019, Mission Shakti. Like that we have got number of technologies. And also you come to the electronics communications. Another important thing is electronics conflict also going to be electronic wars another component. So all these things are going to be future. So we need to work a lot. And then you can see the life science already mentioned. Then microelectronic devices, computation systems for cyber systems. The 7 technology clusters we have got it under the DRDO for work on the different system. So if we talk about soldier support systems, as I already mentioned, it's very, very difficult to work at -35 in the Siachen place. By mistake, if somebody touches the frozen ice, they have to go for amputation. When you talk about night soil disposal, especially for biodigester, our team is working in Antarctica. They brought our bacteria under the frozen ice. They did R&D for several years. Today we got a biodigester for disposed humans -30. For information, whatever you develop, spin up always give to society. One example is, you look at Indian bio toilet. So basically, Indian Railway bio toilet, it's basically developed for soldiers in the high altitude. The same technology now given to Indian Railway. And also you look at your enhance survivability, sustainability, and then efficiency capability. All these things are sent to there are 9 labs working on this particular line. So the performance. When you're in the extreme stress, when you're in the extreme temperature, when you're away from family culture, they will be naturally in demands. So how you are going to make them perform better? It's a very, very difficult task for us. So our team is, and then selection. Everyone cannot become a military officer. Everyone cannot become pilot. So we got, as I already mentioned, there are 200 psychologists take care of SSBs for selection process and also training. We need because now you see the technology development. One side you have school dropout soldier as a soldier. Other side you have high-end weapon system which are completely digitized or even advanced development. So we need to train them. You cannot give idli and sambar in the morning to the for information. As per Indian system, we got one laboratory in Mysore, Defense Food Research Laboratory. There are 32 ration scale. Somebody is in Antarctica mission, somebody in high altitude mission, somebody in the even packaging you look at somebody putting in the high altitude minus temperature self-feeding pouches. Somebody deploying in the chemical biological warfare zone, the package should be non-permeable. For information, the demand for shelf life is 2 years from army. It's a very, very difficult task. Recently, all of you seen our space mission with Indian Shukla is one there. Has carried a completely whatever development in VFRL. Even for Gaganyaan program, parachute, space suit, even space disposal system, or how to eat microgravity, everything we developed by one of the lab. We are closely, 10 of our laboratories closely working with ISRO for your Gaganyaan mission. Like that, we got another thing. We have to motivate them. See, when they are in the extremely environment like heat stroke, cold stroke, hypoxia, pulmonary edema, and then get into the NBC scenario, nuclear, chemical, biological. If you smell chemical like nerve agent, you will die. If you touch your sulfur mustard, you will die. It's blistering agent. Like that, you have a number of challenges to overcome. All of you, what you have seen to it, COVID is not even characterized biological weapon. It is simply an agent. If we talk about real, like botulism toxin, you need a few nanograms to kill the population of 10 to 15 lakhs. So this is what challenge. So for information, for all your chemical warfare agents, we have an antidote. For all your known biothreat agents, biotoxins, we got either drug or vaccine. All of you have seen during COVID, India could sustain, even though global power could not support India. The Coimbatore and Tirupur initially came up to support the coverall face mask. And then ventilator, PhD College of Technology in Coimbatore with Pricol, they developed in 2008. For information, none of the industries placed order for Indian ventilator. The government of India paid 100 crores, got technology back during COVID. Today, India got maximum ventilator in the country. Oxygen. All of you know, liquid oxygen only we breathe in the hospital. Now the scenario has got changed. What we did was, the fighter pilot takes up from runway, draw air from atmosphere, dry it, pass it through material called zeolite, aminosilicoporous material. This is called physical adsorption, pressure swing adsorption model. The particular pressure, it separates only oxygen. Again, it required 100% person. So this is one of the major, based on that, within a 3-week time given by Prime Minister Office, in the Coimbatore Trade and Pneumatics Company, with work with DRDO, we could give the 1,000 liter per minute medical oxygen plant based on the zeolite. All companies like Propel, Gem Equipment, Trade and Pneumatics, even L&T, we given technology for BEML. Now, under PM Care, every district headquarters, we got a medical oxygen plant which can take care of the 300 patients at a time, 1,000 liter per minute. Zeolite lifetime is 10 years. For only thing, we have to admit certain things, we don't make the zeolite in the country. So these are the challenges. And then you can see protective equipments, especially in one of the industry in Coimbatore, we called Siva Texan. They have taken technology from us. In a 7-layer NB suit, can you believe you have to wear and walk for 8 hours a 7-layer suit? One of the layers is fabricated, laminated carbon fabric. It's a very, very difficult task. Can you believe? These are the challenges. And so clothing. One is, as I already mentioned, NTG clothing, underwater escape suit, and then NBC clothing, paradrop clothing. So we have got completely variety of classes of, and also low absorbable clothing for camouflage application, stealth application. Like that, we have got a number of clothing systems. So under the life science category, I think some of you here biology, microbiology, biochemistry, even physics, chemistry people, these are the area. See, now we are looking for every agent, chemical, biological agents, sensors, especially advanced sensors. Biosensor, chemical sensor, electrochemical sensor, perception sensor, and then individual protective devices, and then decontamination. For everything, we need to develop the decontaminating agent, and also again antidotes and vaccines. Operation support, like combat ration, because still the most fundamental requirement is food. So we have to support our armed forces with the proper combat ration, higher fuel capability, which I already mentioned, the waste management is on night child disposal, combat casualty care. Can you believe we got a called capo bag, high altitude pulmonary edema bag, with pressurized bag. That's like a high-end, high-tech ambulance for the soldiers in the high altitude. Put them in the bag, bring them to base camp for treatment. Why I'm telling you, it looks very simple. You get it to the extreme, a very, very difficult system. And also, here nobody will collaborate, nobody will support. That's why the criticalities are there. And you can see now somebody sitting like you in the submarine, they cannot access a doctor. Somebody in the Trans-Himalaya, we have got a 600 ships connected to the telemedicine system now. The doctors, the headquarters. And then you see the physiological monitor. Now we need to monitor soldiers who is in the border, like physiology, body temperature, their movement, ECG, and then it's called wearable sensors. Then anti-G suit, HEPA bag, submarine escape suit, and then submarine filters, what we are developing based on the pan-based hydrocarbon material, which has surface area of 1,500. So where we were able to use this particular material for purifying the air which is available within the submarine. I think all of you know this year the Nobel Prize is given to the chemistry MOF. So now they report 10,600 minutes per gram. It's going to change the game, especially energy storage, gas separation. So there are so many applications like that, And also, now we are given up for agriculture. See, if we go to Leh Ladakh, there's only two crops. Only is barley, another one is one more crop, and turnip and potato. Only the people survive there. Today, now we are doing agriculture in the minus 30. Can you believe we got 15 technologies, including soil mulching technology. Even your Siachen, they have microgrowing laboratory to support our armed forces with vegetables. We have 78 vegetables being grown there. Why you can ask, why don't you, in winter you cannot carry anything there, even aircraft cannot travel there. That's why we are living with soldiers, our science working with soldiers. I want to create impact among the why we are doing so much of investment of R&D. This is what our requirement. There are two plants in the Himalaya, Sibaktan and Labori. The naturally it has got antioxidant and vitamin E. Both are helping on the immune system. Another one is there. This one now, vitamin C enhancement of the memory enhancement, the vitamin E. So now I come to the point. See, many things is engineering based, but still you can tell your colleagues, because now under the 2047, India has to become the global power. For that, you have to be a economic power, military power, and knowledge power. Military power alone not sufficient. We need a healthy India. We need to have a food security. These are big challenges. Without these two, military power going to be. But India is already emerging as a military power. What you have seen in the Operation Sindoor, everything is indigenous developed. So thanks to industries in the India, they are also coming forward to invest and manufacture defense products. India started even exporting some of the items now because we are changing the policies. See now, by considering all these things and also making some of the changes, the message given by government is reform, transform, perform, and inform the government. So there are a lot of changes are happening. It's not so easy to work in this kind of organization. And again, there are 15 center of excellence has been started by this government in 2019. But the first center started in 1998 with Kalam in Bharatiya University. Based on the experience working with academia, now government came forward to develop the centers. Another center, second center came in the University of Hyderabad in around same time. But now we got 15 centers, 9 centers at the IIT, and then 1 center in IIC Bangalore, and then 2 in State University, 3 in Central University. This is set up. For information, under these centers, the DRDO is given 82 research verticals. Every center is national facility. We can approach any center. This is meant for giving for the academia and industry. For information, 5,000 crores budget is allocated per annum. This is a new concept. So we are taking a lot of treating problems, but still it will come up. You can see here. So the first, if you look at the IIT Delhi center, these are the verticals, and then I'll go by trust areas also. See, if you talk about advanced ballistic protection technologies, lightweight armor per soldier, armor per vehicle protection, advanced modeling and simulation techniques, explosive structures, including body armor, then modeling simulation. So here, some of the people working in the theoretical physics like quantum mechanics or computational people can come forward because many things are model based. And then you can see the advanced electromagnetic tetragon millimeter wave technology, especially for your millimetric wave microwaves for radars, 2D radar, 3D radar, for convoy tracking or even direction finding or jamming system. We got source detector devices, and then high-speed tetragon communication, and then imaging, then including IR imaging, then millimetric wave devices. Like that, we have got a number of trust areas. All of you is available in the website. If you look at the drdo.org, under the Directorate of Futuristic Technology Management, DFTM, we've given all these details. You can go through it. If you want to have any doubt, you can come back to us, because now we're trying to connect that's why these centers are called DRDO Industry Academia Center of Excellence. The Center of Excellence will start from little higher TRL level up to 3. Then DRDO will take it forward, realize the product, then hand over to the industry to deliver the product to the armed forces. It's called DRDO Industry Academia Center of Excellence. From hypothesis to marketable product is our response. That's why all these technologies are down to another 20 years, 30 years going to be there. So that's why they are projecting these areas. You can see the brain-computer interface for brain-machine intelligence, like robotic control, and then augmented reality, and then ambience awareness, enhancing inputs via visual mode, or even enhancing inputs by touch, brain-brain communication, brain-to-brain communication. All this are the area. And biomechanical, enhancing biopedagogical capabilities, the enhancement of upper body strength. Because when you put somebody in the high altitude, especially the Trans-Himalaya, it's a very, very difficult part. That we are working closely with industries and this one called exoskeleton. It is for basically to enhance this external arm to support our armed forces, because the moment you go there, they will become, bone will become loose, the muscles become stressed. So this is what another area. And then you can photonics and special optics for laser applications. These are the areas they given in the IIT. And then you can see quantum communication, this free-based communication, and then fiber-based communication, then enhancing activity, and also high-speed imaging devices, thermal imaging, shock imaging, instrumentation for critical test, and again smart intelligence textiles, where we are coated with laminated textiles for aerial infloats, especially when you are emergency period. If you want to para-drop people, in 30,000 feet you have to drop in the one by one. So they have to reach the surface. Why in the emergency period? Say for example, if you want to put somebody in the Leh Ladakh area, they need 3 months acclimatization. It's very, very difficult. We are identifying soldiers based on the biomarkers. So like that we use this kind of one, and then you see the protective, including NBC suit, submarine escape suit, even your NTG suit, all protected textiles, the lightweight textile thermal mechanical protection, camouflage, basically low absorbed materials for invisibility, then variable signature textile using metamaterials, sensing and adaptation to the environment, temperature responsive smart insulation technology for all weather protecting even microclimatic conditions, and then you can see the miniaturized system for cooling suits. Because somebody put in the Rajasthan, the 55 is reported, when the work inside the metal tank go to 62. So accordingly, you have to give them the all over life support systems. So and then you can see the IIT Bombay, the mostly based on the aeronautical based. Here you can see the aero engines, small turbine engines, and then solid propulsion technologies, advanced aero structures. These are all known basically by engineering colleges. And then you can see the hypersonic propulsion for ramjet engine modeling, simulation, and long duration hypersonic propulsion technology, and then supersonic combustion stability, and also the endothermic fuels. And again, advanced conventional manufacturing technology for aero engine. You can see these are the areas. And then another area is hybrid propulsion, electric propulsion, hydrogen. The hydrogen, some of you can think of, because India is aiming to know, we have got under the SDG, National Mission for Hydrogen Energy. See, we have got on scope. So India and Brazil only can achieve this one. We have got a huge bioresources. You can take sugarcane bagasse, rice bagasse, or molasses, or anything you take, got huge. But how you are going to convert this into ethanol or ethanol? Then again, how you are going to convert into which like catalytic converter or splitting into hydrogen. So this one. Another thing is, equally you have to work closely to how we are going to store the hydrogen. That's the biggest is explosive. So we need to, especially when you get into the confined system, it requires a lot of safety system. So these are all the areas one is to work on. So the IIT Madras is available in the research park, 5th floor. We are got power electronics and thermal management system, hydrodynamics control acoustics, and then advanced combat vehicle technologies. These are all for underwater applications. We need to understand the oceanography, biological oceanography, physical oceanography, ocean guard, sonar and distance-based navigation. All the things are given in the particular center. And also another important area we all have to work on advanced rare earth materials. So for example, we talk about lithium. Lithium, there's no scope except China. No country has got. But we have to work on alternative material. And also there are other gallium or gallium arsenide or like that. We have got another materials to work on this particularly in this one. You can see the under here IIT Madras. You can see the 15 thrust areas are given under the one particular hydrodynamic systems. Low noise propulsion system, super torpedoes. Torpedoes is nothing but unmanned vehicle under the water. And then you can see the application of science, conventional hull structure, adaptation, advanced technology for naval system integration, structural health monitoring for naval systems, design and lightweight artillery launching systems, including air, surface, underwater. Then fire control system. Because fire control is a very, very important area where, because as all of you know, this only agent can handle the military fire is a halon. Halon is totally banned. Because of halon, we lost so much of ozone. So we have to work into the alternative to the, which can meet out the halon as a requirement. Because no country can use halon except developing countries. Whatever you stockpile, you can purify and use it. And as you can see, the advanced combat vehicle technologies, like system level research and design combat vehicles, simulation modeling for digital twin technologies for combat vehicle, which are going to be in an underwater system. Then naval integration components, and then battlefield situational awareness technology. I think again, all of you know, the government of India launched deep sea mission. You know what is deep sea mission? Like Gaganyaan, like Chandrayaan, we got a program called Samtrayan. So for that, already our vessel has gone up to 6,000 meters and come back. NIO is a nodal lab, NIOT. Then NIO is also one. Then we are also closely working because supporting them with based on our experience in underwater applications like submarine and other systems. So we are closely working with this kind of systems. And also you can see the advanced rare earth metals, like basically extraction of rare earth metals from Indian mineral sources, and magnetic metal for defense application, then metamaterials for application, metals for high energy density batteries instead of lithium, and also rare earth metals based fuel cell technology for long endurance ships, and then materials for IR and microwave signature control, and also recovery of rare earth metals. These are the areas we are looking for the proposal from the academia. And then University of Hyderabad exclusively for the high energy materials, all explosives, and you can see the high energy materials like computational modeling for high energy molecules. So somebody can take quantum mechanics people can think of this kind of then novel materials for synthesis and characterization, and also insensitive ammunitions, the high explosive pyrotechnics. All these are the areas, and then technology for handling explosives. See, handling explosives are very, very difficult task. For information, we call it as a STEC, Storage, Transport, Explosive Committee. We got 21 volume of stockpiling, processing, transporting. It's a huge task. All of us cannot enter the explosive storehouses. Our bioenergetic power is sufficient to initiate the explosion. And also now we got into new called igloos, where instead of storing 5 tons, we are on up to 300 tons a single building. SCRC Chennai and our lab jointly worked on. Now we are able to store 300 tons of explosive single building, acceptor and down is called igloo model. Otherwise, no, if you have one stockpile, another storage can be up to 15 kilometers. It's very, very difficult in the border areas. So this is an area where we are moving on to this kind, because we got 13 ordnance factory and ordnance factory board. So these are the required technologies. You can see we have got computer science based University of Gujarat. Basically, these are the thrust areas like vulnerability discovery and exploitation, IoT security, malware analysis, cryptocurrency analysis, and also big data analytics. You can see these are the thrust areas under the University of Gujarat. So everything available in the website. You can Google it if you have any doubt, because these are all major systems. You can also think it out how we can support this kind of technology by like small technology, a system, subsystem, or spares. I think you can come forward. And also you can see the IIC Bangalore, completely on aerospace systems and materials, item-based materials, and then micro, nano systems and technologies, AI and robotics. And also you can see the test areas given under the, for information, they got 260 crore project they're running now under the DACOE. So it is already today Varsans are told the success rate is also again less, again everything going to IIT and IISc, but nothing wrong in it. But now we are encouraging the tier 2 institutions, because where we have got a extremely talented manpower and human resource, so that we have to harvest it. And also another thing, we have difficulty in managing certain systems. That's why we are coming forward. See, kind of there are 9 technology areas given. Then you can see the Mizoram. Basically, agro-bioresources for soldier survival, defense-based management, including natural disposal, the harnessing environment, soldier survival. And again, we also have a behavioral science under, particularly under the cognitive sciences, and also behavioral mechanism, then even follow-up profile, everything, human engineering. We have got a system in the another area in the Mizoram. And Central University of Jammu, basically for sensor-based semiconductors, is not yet launched. But these two are the areas. This is Kalam Center of Excellence at Jammu. So this is our center. It's located in Bharatiya University. So we already done a lot of things. Especially we are able to develop the crystals for IR sensing by TGA crystals. We could develop the thin film based for night vision cameras. We also developed during COVID. All of you see in the antibody is the biggest challenge for diagnosing the COVID infection. All of you know we take antibody from either from the horse blood or even the rabbit by killing and separating the antibody. Now, one step forward, we started from Coimbatore. One of the professors working in the PhD College of Arts and Science, Michael, he started somewhere around 20 years back for snake venom. Today, same technology. Today, so you take any toxin, when you get exposed, your body tries to develop the antibody, except superimmune system. So, same way, we could immunize a chicken with particular toxin. If you talk the egg-laying chicken, 1.5 years, from every day, from every egg, you can develop the 100, you can purify the 100 milligram of antibody. This is what an innovation. So now from the egg yolk, you can develop the antibody. This is a monoclonal antibody, which can use for all therapeutic or diagnostic or therapeutic application. This is what we have done it. Like that, we also have some of the other areas, like selects-based, basically our aptamers, the chemical antibodies you could develop for diagnosing this kind of infections. So another thing is environment toxicity management. It includes everything, including chemical, biological agents, including toxins like aflatoxin, even gerulutin toxin, all microbial toxins. For information, aflatoxin can stay in soil for 48 years minimum, even 100 degree beyond temperature. And all of you know, recently our friends are getting diagnosed with cancer. You know how it has come? The food cycle, food system only. So for example, if you take maize or even peanut or some of the things, we store it for 6 months in the closed system, it develops the aspergillus or some other aflatoxin. So what will happen? These are all toxic in nature. These are all carcinogenic in nature. Instead of disposing, we are giving to cows. So through cows, you are consuming milk. That's why even the nanogram triggers your cancer. This is, and also you can see many people are talking about organic agriculture. You know what we did in the green revolution, the right and left you use fertilizer and pesticides. Once you spray the DDT, it remains in the soil for 60 plus years. Then where you call it as it's organic agriculture? And where is technology available to analyze your BD? So how can you say nil? You don't have technology to say nil. You can't below reduction limit. So these are the challenges. So that's why we are and another thing, respiratory support system. What I want to hear is if somebody in the high altitude, there's oxygen. There's no pressure to breathe. Somebody in the submarine, there's limited air for 3 months. So these are all, somebody in the fighter aircraft, 50,000 feet, we need to supplement 100% oxygen. It's very, very difficult. It's called onboard oxygen generation system. We call it as ILSS, Integrated Life Support Systems. So these are the challenges. So like that we work on, and also natural polymers and polymer for different applications. We wanted to have a next generation polymers because we have more of application like other aspects. Even natural polymers should take a azobacterium, which produces like handkerchief in 14 days of incubation. If you analyze that particular cellulose, bacterial cellulose, especially for bacterial efficiency, 99.999, it won't allow it because the cross-linking. And also you take the water holding capacity 100 times, you can use this kind of material, natural material, especially when you go third degree wound in the fire wound and all, because there's a huge water holding capacity, it becomes very soft material, excellent contact property. So this kind of material can be used for this kind of advanced application, including third degree, fourth degree, and also it can be one of the layer in the NBC filter. So you can see these are under the we call it as CBRN, chemical biological countermeasures. You can see the biomarkers for adverse situation, forensic countermeasures evaluation, and then development infrastructure protocol, targeted immunosensors, and then genomic sensors and biosensors. The biosensors are one of the major requirement for all your agents. We need a sensors. And then environmental toxin management, export disposal, NBC, nuclear biological chemical disposal management, CBR and protection technologies. The respiratory support, like ventilators, oxygen generation, low pressure oxygen deprivation, the decompression of divers in the undersea, deep sea, respiratory system for hyperbaric environment, solar powered auxiliary power systems, geolite. It's called aminosilicoporous material. So we need people to work on the developing the geolite. We are going on now the project IET Tirupati, the 2 crores. They are going to start with synthesis with silver impregnation because lithium already there. But lithium is, it may not be, feasible in the future. Now we have sodium, we dried it, but sodium, the problem is the lifetime is a big problem. So now we are moving on to this kind of silver-based geolites. And also liquid breathing fluids from underwater deep sea. And then natural polymers, high tensile strength, and ultra lightweight structures for portable canopies. These are the areas we are looking for. Then IIT Hyderabad, we got these are 7 verticals. You can see ultra high temperature materials for hypersonic. It is all missile based. All these 7 technologies are basically because Hyderabad is a missile hub. So all these systems are given to the especially AI for missile and missile defense, and then space system, and because now we got a base defense program. That's why under that program only we could develop the anti-satellite missile called Mission Shakti in 2019. It's called DSP, Defense Space Program. Though here you can see the power thermal management and space robotic platform, adaptation technologies, and then defense mechanism for satellites, space debris modeling. Because you look at today, every country is operating with only satellites. If you look at space, become completely debris because of the all life expert satellites. So another area where we are have a lot of things. And then adaptive imaging, like ALML based image processing, and also high spectral, multispectral SAR based optical images. Also nano Ethernet technologies basically for nano Ethernet, then flight control and related technologies, and also testing and methodologies, sensors and payloads, for nanoathletes, and then SWAM application, the system integration, all these comes under the particular, then sticker and homing, and then additive manufacturing. These are the 3D printing. Additive manufacturing, including, even developing the, using 3D printing, developing the human organs and other systems. Like that, we have got even mechanical side, even metal printing they have developed for this kind of systems. You can see there's so many, opportunities are available. You can see, you can Google and see. IIT Varanasi, we have powder metallurgy. Here we have a lot of things for material science people. You can see the indigenous development of the IGA, PRPA part, the powder production, additive manufacturing, the grade powders, computational modeling and for AM materials, numerical studies, and then investigation of material properties for metal alloys and developed through AM, additive manufacturing. Then ceramics, functionally graded materials for composites, for glass composites, then process, fabrication, character of ceramics, and also functional materials. These are all for some of them of the paste application or even for metallurgical application. And then functional materials, high thermal conductivity, and then RF, radio frequency filters, paste shifters for microwave, the high purity silicon carbide material, and then polymer-based high temperature additives, low corrosive, low weight, higher damping materials for electronics, even PCM material, and then structural applications, endothermic fuels, organic, inorganic, hybrid functional polymers. All the things are under the IIT Varanasi. And then one more, high power microwaves and sources devices, like components for high power microwaves, and then Gigtron, then EIK, all these things comes under the particular center. So here, Jodhpur, we have another center basically for desert warfare, like war gaming, convoy tracking, camera-based materials, stealth materials, and also here the futurist common mobility system, AI for information and war gaming technologies. These are the 3 areas from the IIT Jodhpur. IIT Kanpur, we got flexible printing and flexible substrates, advanced nanomaterials for actual material for design and development, high energy materials, bioengineering and energy regulation, and then establishment of hypervelocity, expansion tunnel test, and then fluidic test, and also you can see the design and development of the reconfigurable electrochemical machining center for rocket cells, and also dynamic stability for hot dark system used in the aerial fueling. Kharagpur, we got smart structures for coordinate structures, defense application, energy storage devices, and also landslide and snow avalanche. There people can use like remote sensing based tools. Like our cyclone, that's the biggest problem in the high altitude because of climate change. We have got avalanches, the biggest, especially because chassis in the Manali, even your Sikkim and other places. So remote sensing based things can be used here. The pulse lasers, specialty fiber, shock and electronics and thermal management. These are, and IIT Roorkee, we have got these are the areas. Kharagpur, directed energy systems technologies, unmanned underwater robotic technologies. So these are all major areas. If you look at, we are given subsystems, first areas. Under that also you can think of something because, say, for example, you talk about nanometal for extractive metallurgy, it has got a lot of subsystems. So if you want to have if you have any idea, you can write to the director, they connect to the scientist, because now the task is given by government. Every scientist have 2 projects in academia. That's what we are all trying to make a more awareness among the academia and industry. Then, in addition to these 15 centers, we also have 4 research boards. One is Armament Research Board, Aeronautical Research Board, Naval Research Board, Life Science Research Board. So here the limitation is the funding will be up to 1 crore, but center of excellence there is no limit. You can go up to even 5 crore, even 10 crore, they have taken projects. So these boards, you can very well, from academia, you can think of taking center. See, it's not very, very difficult because we are very well defined our problems. Maybe you have to think it, you can apply your mind and also come forward. These are all possible. But some of the area we are supporting even S&T also because everything cannot just like that you can make a product or you can go to tier level 3 or 4. Some of the area we are supporting even with the basic research component also. We have got, there are like Naval Research Board, like in light materials or hydrodynamics, sonar, signal behavior. Sonar is nothing but sound and distance based navigation in the underwater. And then ocean environment like oceanography, like biological, physical, chemical oceanography. Then scientific computing, then marine systems, including marine current and hydrovibe hypothesis. All these are the comes under the Naval Board. We got LSRB, Life Sciences Board, under the life support system for biomedical devices, including exoskeleton, all biosensors, chemical antidotes, the soldier health and drug development, and the physiology of extreme environment and behavioral sciences, and then biotechnology and bioremediation. The biotechnology here, what we are looking for, developing, identifying the soldiers which are biomarker based, and deploying people in the altitude based on biomarker based. Like that we have what? Then food and agriculture for bioprospecting based on the altitude. We also support the academia through S&T project, basic research project, which may not be even relevant to DRDO. We are supporting the aspect. You can see we have got the extramural research and intellectual property directorate. We also work for provide financial support to the organizing conferences, workshops, and topics related to DRDO initiatives. So somebody can think of getting the funding. Every institute is given 2 funding per annum. If somebody comes application relevant, we are always supporting with the particular this one. Now, here under Make in India, we got TDF, Technology Development Program. Here, this is majority for industries, funding up to somebody's developed technology. It requires further development to induct a system in the Army or Navy Air Force. 100 up to 50 crore per project. The Coimbatore industry called Sakradara, they are working on the landing gear for AMCA aircraft. They've taken the 22. You can see it's not a loan, it is a project. 50 crore, they have to, even they can all expenditure related to labor, everything they can meet out under this particular program. We are even funding to academic in the industry also. So one of the major program under the it is under the Ministry of Defense, and the DRDO is executing this one. It's called Make in India program. So focus will be on the development of technology that will form kernel components, assemblies will be in turn used to develop defense equipments and also even systems or subsystems. It may not be a major system. This is what the TDF is given. We have got society. Basically to promote the, because the gray area in the biomedical system, especially for armed forces, exoskeleton or even some of the areas, there won't be civilian requirements. So we got here like DBT, DST, and then Department of Family and Welfare Joint Agency. So we got huge funding for this particular society for the biomedical system development. So this is also one of the SBMT. And then you can see for skill areas for electronic communication engineering, like radio frequency micro engineering, antennas, radars, communication systems, PCB design, testing, VLSI. This is all another area because it's semiconductor area. And then signal processing for radar signals, sonar signals underwater, networking, cyber security. All these things are we have got jointly doing the PCB electronics. So this already I spoke about life support system biomedical devices, like fabrics for textile with protective clothing, brain-computer interface for sensor instrumentation for relevance to the military application, and then neuro exoskeleton. Exoskeleton is one of the major requirements. Now we are going to use this exoskeleton for even for rehabilitation of somebody lost in the legs or arms, even paralysis people. It's going to change because for that we have Armed Force Medical Corps close to working with us, and then combat medical support technology and device development. Then pre-hospital care, combat casualty, traumatic brain injury, soldier health development panel. These are they are looking, including radiation countermeasures. Then we have got that physiology of extreme and behavioral sciences, and then we got biotechnology, bioremediation like surveillance. We need for field deployable, even dot based, or even sensor based, or even paper based systems. Then vaccine and post-exposure therapeutics for biothreat and chemical warfare agents, host-pathogen interaction, especially the biothreat agents. This is another area, and then herbal especially in the Northeast, there are 3 major problems: snake bite, vector-based diseases, and then water. Water is completely either fluoride or arsenic, even beyond 3 to 4 ppm. So these are all carcinogenic in nature. So we are household-based water treatment systems, and then metagenomic and metaproteomic approaches for identification of the microbial pathogens. So life support medical devices like biomechatronics and human augmentation, brain-computer interface, non-invasive brain simulation, and then gas separation. So that inert gas separation like zeolite and hollow paper. Hollow paper membrane is another area, is one of the area where we require a lot of people to separate the gases in the complicated system. And then next generation insulation material for sub-zero glacier temperature. So whatever we have got, the insulation, especially for NBC suit and other aspect, we don't have sufficient insulation materials. And then shear thickening polymers for anti-stab resistant structures, then high temperature resistant phase and fabrics for like we have got ECW, and then we have got extreme chemical climatic weather, and then heated textiles for PCM materials, micro devices. The chemical biological defense, you can see we got areas like biosensor, medical countermeasures, universal decontamination solutions, vaccine candidate. See, every country came with vaccine during COVID. India became the hub for manufacturing. And also only country could develop the drug against this COVID is this lab called INMAS. It's called 2-deoxyglucose, 2D. 2-deoxyglucose drug, anti-cancer drug. It is only drug India could develop. No country could come with drug. Every country came with a vaccine. Only difference is efficacy and the side effects. But India could develop the 2-deoxyglucose. And then drug development, soldier health, especially for radiation countermeasures, organoid models, regenerative biology, and then biomaterials, biosimilants, bioidenticals. All these things are area comes under the soldier health development. See, in the long term, advanced soldier, see, jet suit. So jet suit is not, it requires a lot of this. One is material, and then lightweight, composite, sensors. So we have got the advanced soldier flying, integrated exoskeleton with the exoskeleton, and then tools for cognitive enhancement, and then air management in confined environment like submarine, the next generation life support system for airborne applications, and then detection of sensors, chemical, biological, nuclear for applications. CBR and protective gear, smart and long-lasting, self-life inductive, self-detects and decontaminations. And decontamination like for your all matrices, thermal comfort, the survivability, high altitude adaptation, survival in treatment, and then compactation, high energy, energy bars, energy capsules, energy space systems. So these are the areas where we are looking for academic support. And the military psychology, see, whatever may be your military strength, without military psychology, nobody can win the war. Including what we did during our Operation Sindoor, entire country is aiming that tomorrow there won't be exercise in every capitals, state capital about the military. But the same night, they diverted complete focus towards Pakistan. So like that, we have got military psychology is another area, especially trust estimation and human-machine trust. So this is another area we can think of, because we don't do much in the military psychology area. So this chemical defense, you can see the sensing materials for chemical warfare agents like metal oxide based, carbon nanotube based, graphene based, hydrogel based, or luminescent, or biomaterials. These are areas for are also self-indicating product systems for self-indicating materials like sensors, integrated protect devices. The high surface area adsorbents like activated carbon vaporic or even MAF, this kind of material for like lab scale process for adsorption and data for chemical warfare agents, and also toxicity data. So this, this I will skip it. And here you can see the liquid crystal technology for armed fiber formation. Since a PN-based fibers for suitable carbon fibers, and also spinning of armed fibers with jet weight spinning, 2.5 gigapascal strength. And then you can see the remove CO2 from the confined environment to convert into liquid organics or oxygen with the minimum hardware requirement. So this is another important area where we have to think of. So another thing, now earlier it is called defense British laboratory. Now we focus on the defense biodefense technologies, because biodefense is going to be another area where civil military, nutrition, microgravity, space conditions. You can see how they are working with various like development of prototype for on-site water generation, and also equipment for space microgravity conditions, also electrochemical catalysts for electrolyzer-based systems for carbon dioxide production and concentrated acetate, and then simulation of models for studying effect phase radiation on nutrition during the long-term space missions. And also develop the available models like Monte-Carlo model and molecular dynamics simulation to simulate the how space radiation affect the nutrient stability when they go for long days. So here, sorry. Focus here, DRDO Center of Excellences. You can see the DRDO Center of Excellence are at the forefront of cutting edge research, fostering the breakthrough in the defense technologies, and also strengthening the self-reliance through indigenization. Center of Excellence aim to reduce the independence and the imports, and also Indian strategic autonomy, enhancing collaboration by integrating academia, industry, global partnership. Even now we are open to the global partnerships, and also Center of create the dynamic ecosystem for advanced defense R&D systems, and also pioneering the disruptive technologies like focus on AI, quantum technologies, hypersonics, and also future-ready defense capabilities like building robust, adaptable, sustainable solutions for the adults evolving security and challenges. These are the major aim what we are looking for, because recently launched centers, just 2 years we have started developing this particular concept. I'm sure future the centers are going to support our all armed forces for the down the year for 2030, 2050, or 2060, whatever they wanted. And also DRD is not just investing future, engineering the empowering India's defense forces with state-of-the-art innovations to ensure the national security, and also to become the global leadership by 2047. With this message, I thank you everyone for this opportunity. This Center of Excellence started by Dr. Kalam in the 1998 Bharat University campus. You have got a 75 crore facility for all your material synthesis and characterization, all chromatography, all spectroscopy, all molecular biology systems are available here. Even we are supporting academia for use this facility for many people. Thank you very much. Any questions? Please come forward.
Take few moments for asking questions. If there are any questions, please raise your hands so that we will bring the mic. And there, one person needs mic over there.
Sir, I missed out. Can you slide for nimsa? IDEX, sir. IDEX is Indian Defense Excellence. It is a Ministry of Defense
Good afternoon, sir.
Program. Anybody can take part. MSMEs or even incubators or anybody startups. For that also we are giving funding. For starting from 1.5 crore to based on your program. It's called IDEX. Sir? We can go for non-linear dynamics and even convoy tracking, even cryptography. India is very, very important. We need, because every 200 kilometers is different language. So we need to have a mathematical model to decode the language for the cryptography. Mathematics we are using. Even many of your wargaming are based on the mathematical models only. Cryptography, sir. IDEX. IDEX. Innovation Defense Excellence. It is common problem come from Navy, Air Force, DRDO, even for Partnership Board, even public sector, like Bill, BEML, BDS, everyone put their idea there. So anybody has they can, it's called IDEX. Some slide was there, I don't know where I missed it. IDEX is there for open for everybody. Anybody can take up.
Good afternoon, sir.
Sir?
Sir, I have a question.
Just. In more centers, sir? No, sir. Center is limited to only 15 centers. There's scope for increasing verticals. Because these are all we are trying to develop, because it's very difficult to convince government and also come forward and also there should be people to work on, because they're all high-end system. Because we cannot. That's why I told you, if you look at as this is vertical or trust area, looks very odd. But you have to work it on subsystems, spare, small systems, so that we can think of. So this is all the broader area we are given. Under that, so many systems can be taken up. Sir, it's common for everybody. Sir, all centers are located in the 15 institutions, national facilities. Any proposal comes to particular that center has to fund it. That Bharat University is a host for these 4 verticals. They have to fund anywhere. There's no limit, sir. That's why I told you. Earlier, when we started as a Center of Excellence in 2005 or 1998, it's a captive particular institute. Now that theirs are gone now. So anybody competitive, they can apply and get it. Suppose you have some idea, you can take IIT Delhi, they will give you funding. That's why there are the possibilities are available. The huge money is allocated. So we are having a lot of difficulty. See, it's not your mistake. We have not made a proper awareness. And also, even this is not sufficient. We need to work on even further level. Trust area alone is not sufficient, because we have to make it further. We have to work models. We have to make it a small system, split small system. But tell people this is what I want from academia. Otherwise, it looks very grey area. Madam, please.
Good afternoon, sir. Thank you for your valuable talk regarding this DRO supporting schemes. And I have a question on, you have mentioned technologies for handling explosive as well as soldier survival. Then how do we employ artificial intelligence for early detection of explosives?
Madam, explosives, see, any technology, especially for this kind of handling chemical weapons, biological weapons, so if you make up models, so for example, if you want to take any of your rockets or any missiles filled with propulsions, after 5 years become obsolete. is one of the global problem. So you cannot apply physical, mechanical, or even chemical energy to dispose chemical. So maybe we require modeling to how to develop. This is all in area can make it. What I mean is explosive, obsolete explosives.
That's why artificial intelligence now is
Yes,
demanding
yes.
technique.
The AI/ML is very well there.
Yes. Then I have another
For
question.
information, now many people are marketing AI in the country, but AI lab was established in the 1986 in our country. 1986, Dr. Rajaramanna, Dr. V.S. Arunachalam, Dr. Kalam, they could convince government, CAIR, you can Google it after my lecture, Center for Artificial Robotics, the laboratory established in our country in 1986. So this is what our strength. We had visionaries. See, and also, we talk about any of your today's successful stories, including BrahMos or even Akash or Agni or Prithvi or Dhanus, take anything. We started the program only in 1982. The first launch of missile only took place in 1989. Within a span of 40 years, India could emerge as a global leader in the supersonic missile. So we have to appreciate our government as well as our people. So we start comparing with the developed countries. So this is what So we have limited investment, with limited here there are things no country will support. BrahMos, of course, it's a joint venture between Russia and India. Talk about other technologies. You take light combat aircraft today, Tejas. Today is global 5th generation better aircraft. You take main battle tank, which is being developed in the Avadi, Chennai. You have got a missile tank, missile firing capability, even unmanned tank, Arjun, Ajaya with unmanned system now. So this is what the capabilities.
Thank you, sir. I have another question.
ML is there everywhere. If you are able to know, this is where we are looking for people, but it has to be in a prediction and you have to correctly propose, they will fund you, no problem.
Sir, I have another question. You have mentioned ARMEMB will exclude funding for hardware system. Why is that?
It is called Armament Research Board, madam.
Yes.
Anything related to small weapons is called armament. Like Pinaka, rocket, MK-47. So you can Google it, Armament Research Board. Areas are given. Only thing is funding is limited up to 75 lakhs. But the Armament Research Board, they also give for funding for conferences. So all of you can first try to understand the conferences, invite people, to talk to people. So this is the way you have to, because as I already told, so far we are till 80s, we are not given funding. Now slowly coming forward. And also now we started interacting with other ministries, with academia and industry.
Thank you, sir. Last question. What are the funding schemes available, especially for science candidates, and how to write a winning proposal, sir?
Madam, the funding scheme, as I told, Extramural Research Directorate, all research boards, SBMT, some of the centers are funding the science also.
Thank you, sir.
And also we have got CARS, contract agreement with subsystems, which are not covered under this one. Directors themselves can give the project.
Any more questions? If there are no questions, shall we wind up the session?
Any help required in this particular DAA COD base, because ourselves we started in the 2021 only, because we had a COVID period. Normally we started establishing. Please come forward, the huge funding is available. Only thing you have to work exclusive to the armed forces requirement. So we have to come one step forward. So that's because after all you are going to work for the armed forces. Because they will not be engaging with paper. Of course, paper is important, patent is important, but look beyond that one, where you can extend your capabilities or knowledge caliber. Thank you.